Welcome to the Explainer. Today, we are putting on our digital detective hats to map out the hidden infrastructure of the web. We're going to dive deep into a foundational pillar of web infrastructure analysis, directory discovery. We'll be exploring exactly how security auditors uncover vulnerabilities and structural paths that seem completely invisible to standard users. So let's decode the hidden web.
You know, it really makes you wonder what actually lies beneath the polished surface of the websites you visit every single day. It's a fascinating thought, because the truth is, what you and I see on a public website is just a microscopic fraction of its actual size. It's basically an illusion of simplicity.
Think of it like this. There's the polished storefront, that structural surface designed specifically for us, the public consumers. It's clean, it has clear navigation, and it guides you exactly where the company wants you to go. But underneath all of that surface-level polish is a massive, hidden maze. We're talking about a vast, chaotic web of hidden structural folders, temporary code backups, configuration panels, and developer testing rounds. It is entirely out of public sight, yet it literally runs the whole show. Okay, let's dive right into this blueprint. We're going to deconstruct directory discovery from the surface layer all the way down to the software mechanics by looking at 1. The digital blind spot. 2. HTTP brute forcing explained. 3. Dirsearch, the gold standard. 4. The multi-threaded engine. 5. Word lists. And 6. Decoding web status codes.
Starting off with Section 1, the digital blind spot. Uncovering this blind spot is absolutely crucial. It's the ultimate competitive edge for aspiring security auditors.
See, there's this really dangerous assumption made by a lot of web application developers. They think, well, if a link isn't explicitly published, no one's ever going to find it. They build this entire backend maze, they leave out backups and testing grounds, and they just don't link to them on the public homepage. They assume unlinked pages are safe. And honestly, this structural assumption is quite literally one of the single greatest security flaws on the modern internet. It creates these massive vulnerabilities that are just waiting to be found. Which brings us to the solution phase in Section 2, HTTP brute forcing explained. Now, HTTP brute forcing, which is frequently called web directory fuzzing or content discovery, is definitely not about blindly guessing what a web server contains. That's a huge misconception. It's actually a highly structured, automated exploration technique. An analyst will use a utility to rapidly transmit hundreds of thousands of HTTP requests to a target server, and they meticulously change the path suffix with every single attempt. Picture this. You walk up to a massive, sprawling building. In your hand, you hold a list containing thousands of common room names. You don't just stand there guessing, right? You systematically walk down the hall and knock on every single door on that list. If a door doesn't exist, the building system tells you immediately. But if a door opens, or if it gives you a restricted access signal, boom, you've just discovered a secret space. In web terms, if you knock on a path like /backup.zip and the server gives you an active download, you've just exposed a severe data risk using pure structured automation. Now, I know the word brute forcing sounds kind of aggressive, maybe even damaging, but here's a really interesting professional insight. HTTP brute forcing is completely non-destructive. Ethical professionals use it because it doesn't alter, corrupt, or damage remote server files in any way whatsoever. It simply interrogates the server's public routing registry to see what responds. That's it. And that makes it an invaluable initial assessment tool. Let's look at the specific tool we use to accomplish this massive knocking process in Section 3, Dirsearch, the gold standard. Among the vast sea of scanning software available today, Dirsearch really stands out. It's written completely in Python, operates as a command line tool, and is designed with a singular focus: directory and file brute forcing. We're talking blistering speed, deep configuration depth, and supreme structural reliability. You see, traditional scanners often just choke on modern web protections, or they spit out these overwhelming, unreadable data dumps. Dirsearch actually uses advanced structural logic to filter out all that noise. It effortlessly bridges the gap between complex network data and clear, actionable findings in seconds. Let's peel back the first layer of its anatomy and look under the hood. Section 4, the multi-threaded engine. Look, speed is everything when you're analyzing massive corporate web deployments. If a tool sent requests sequentially, meaning just one after another, scanning a comprehensive list of 50,000 words would take hours, maybe even days. It's incredibly inefficient. Dirsearch, however, uses multi-threaded scanning. It establishes dozens of concurrent, simultaneous connections to the target web asset.
By distributing the list across multiple computational threads, tasks that would normally absolutely paralyze an audit are wrapped up in a matter of minutes. Plus, these threads can be scaled up for high-capacity environments or scaled down to preserve stability on fragile, older architectures.
So, if the engine is the muscle, we need to look at the intelligence that drives it. Section 5. Word lists. The brute-forcing brain. An automated scanner is truly only as smart as the word list you feed it. A word list is simply a text file populated with thousands of potential directory names and subfolders. But how you use them, that's what separates amateur button pushers from highly compensated consultants. Dirsearch comes bundled with default targeted lists compiled from real audits, filled with historical hotspots like admin or WP content. But the best strategies use contextual customization. If you're analyzing an application built on ASP.NET, you swap out those general dictionaries for word lists rich in specific Microsoft ecosystem paths. This creates what we call the discovery loop, ensuring absolutely no hidden login panel or backup archive remains invisible.
Moving on to our final section, let's see how this builds into actionable intelligence when the server finally answers our knocks. Section 6, Decoding Web Status Codes. When Dirsearch sends a request, the server answers with an HTTP status code. This brilliantly illustrates exactly what we find. If you get a 200 OK, the path exists and it's publicly accessible. Boom, that's an immediate point of interest for investigation. A 301 or 302 redirect means the folder exists but routes the user elsewhere. This often reveals hidden internal staging portals. A 403 forbidden means the directory definitely exists but administrative rights are needed to view it. That is a massive find, proving a secure perimeter asset is active right behind that wall. And finally, the 404 not found means the directory simply doesn't exist. Dirsearch intelligently filters these out by default, keeping your terminal totally clean and focused purely on the real anomalies. Well, we've covered the blind spots, the engines, the intelligence, and the results. But I want to leave you with one final provocative thought to take away from this explainer. If web developers out there assume unlinked pages are completely hidden, what exposed data is secretly sitting on the websites you use every single day? The hidden maze is out there, guys. It's just waiting for the right knock.